Rhea! For today's video, we're gonna learn on how to solve the lateral and surface area of a solid. But before that, we are going to define each solid, introduce to you the formula, and solving examples which are related to our topic. Let us differentiate first the lateral and surface area. Lateral area. Lateral area refers to the area of a solid, or it is an area of any solid. Is the product of the perimeter of its base and the height. For the total surface area, it refers to the net area which includes the base, or it is the sum of the lateral surface area, base area, and top area. Now, let's proceed to the lateral surface area and the total surface area of a prism.
Hi, this is Eliza and I will show you how to find the lateral and surface area of a prism. But before that, let us define prism. A prism is formed by two parallel congruent polygonal faces called bases connected by faces that are parallel.
Or, in simple words, prism is a 3D shape in which the top and bottom faces are the same shape and size, and all other faces are rectangles. There are many types of prisms depending upon the shape of its top and bottom faces or its cross section. Let's see. First one is triangular prism. This is a triangular prism because its top and bottom faces are triangle in shape, and all other faces are rectangular. Another type of prism is a square prism because its top and bottom faces are square in shape, and all other faces are rectangular. This is the same as the cuboid shape. Next is the rectangular prism because its top and bottom faces are rectangular in shape, and all other faces are rectangular. This is also the same as cuboid. Another type of prism is pentagonal prism because the top and bottom faces are pentagon. All faces are rectangular in shape. There can be more types too, depending on the shape of its top and bottom faces.
So, in finding the lateral and surface area of a prism, we have two different formulas. For the lateral area, we have lateral equals perimeter times height. For the surface area, we have surface area equals lateral plus 2 times base. Or it can also be surface area is equal to perimeter times height plus 2 times the base. Now, let us try to solve an example. Find the lateral and surface area of a rectangular prism with the length of 11 feet, a width of 9 feet, and a height of 4 feet. The formula for the lateral area is lateral equals perimeter times height. But before that, let us find first the perimeter of the rectangular prism. The formula for the perimeter is 2 times length plus 2 times width. So it will be 2 times 11 plus 2 times 9. So it will be 22 plus 18 is equal to 40. So the perimeter is 40 feet. We now have the measurement of the perimeter. Let us now proceed in solving the lateral area. Lateral equals perimeter times height. So the perimeter is 40 and the height is 4. Let us now multiply it. We get 160. And the lateral area now is 160 square feet. Let us now find the surface area. Surface area equals perimeter times height plus 2 times base. So it will be 40 times 4 plus 2 times 9 times 11. So it will be 160 plus 198. The surface area now is 358 square feet. And that's how you find define the lateral and surface area of a prism.
Next is let's learn about the pyramid.
Good morning, everyone. My name is Ruthie Mirat.
Let us define first what is pyramid.
Pyramid is a polyhedron formed by connecting a polygonal base and the point, called the apex. Each base, edge, and apex form a triangle called a lateral base. It is a conic solid with polygonal base. It is also a monumental structure with a square or triangular base and sloping sides that meet in a point at the top, especially when built of stone as a result of vegetation aging.
What is pyramid? In simplest words, pyramid is a 3D shape where it has a single base which can be of any polygon shape like triangle, square, rectangle, and pentagon, and all other faces are triangular shape that converge to a single point at the top, which is called apex. Most common pyramids are with triangle and square bases. Here are examples. This is a triangular pyramid because its base is a triangle and all other faces are triangle and converge to a single point. This is a square pyramid. This is a square pyramid because its base is a square and all other faces are triangle and converge to a single point. Next is a pentagon pyramid because its base is a pentagon and all other faces are triangle and converge to a single point. Now, let's try to solve an example on how to compute the lateral and surface area of a pyramid.
Find the total surface area of a regular pyramid with a square base if each edge of the base measures 13 inches, the slant height of a side is 14 inches, and the altitude is 12 inches. Given, the base is equal to 13 inches on each side, slant height is 14 inches, altitude is 12 inches.
The formula of a lateral area is 1/2 times perimeter times slant height. For surface area, it is equal to lateral plus area of the base.
The formula of the lateral area is L equals to 1/2 perimeter times slant height is equals to 1/2 4 times 13 times 14 is equal to 364 inches squared. For surface areas, S equals to L plus B or lateral area plus base is equal to 364 plus 13 squared is equals to 533 inches squared.
So that is on how to compute the lateral and surface area of a pyramid. Next is cone.
Hi, I'm Adrian Reyes, and in this section of the video, I am going to discuss cone. Cone is a geometric figure that is formed by two lines connected with a common point or what we call vertex and the circular base. Cone can be drawn into two, which is right cone and oblique cone. It can be distinguished by drawing a straight line from vertex to the base, or what we call axis of the cone. If the axis draw a perpendicular line to the base, then it would be called as right cone, and if it's not, then it would be oblique cone.
This is a cone. It has only one vertex, which is the tip of the cone. It has only one edge, which is round in shape. Now let's see its faces. One of the faces is round shape on its bottom. The other face is curved faces of the cone that wrapped around it. Now let's try to solve an example.
In solving an area of a cone, we can make use of the formulas lateral area is equals to pi multiplied by the radius and slant height. Slant height is the distance from vertex to the edge of the cone. And surface area is equals to lateral area plus base, or surface area equals to pi multiplied by the radius and slant height plus pi multiplied by the radius squared. Now, let us apply the formulas in the problem. Find the lateral and surface area of a cone with a radius of 12 meters and 5 meters. In finding the lateral area, we can make use of the formula lateral area equals pi multiplied by the radius and slant height. Substitutioning the given, and we will have lateral area equals pi multiplied by 12 multiplied by 5. And after the substitution, we can now identify the lateral area of a cone, which is 188.50 meters squared. After knowing the lateral area, we can now solve for surface area. We can make use of the formula surface area equals pi multiplied by the radius and slant height plus pi multiplied by the radius squared. Substitute the given to the formula, and we will have surface area equals pi multiplied by 12 and 5 plus pi multiplied by 12 squared. Right after the substitution, we can now solve for surface area, which is 640.88 meters squared.
And that is the lateral and surface area of a cone. Now, let's learn about the cylinder.
Hi, I'm Mrs. Jan Verzola. I'm here for today to teach you how to solve the lateral area and surface area of a cylinder. First, let us define what is a cylinder. A cylinder is a group geometric solid that is very common in everyday life. If you take it apart, it has two ends called bases that are usually circular. The bases are always congruent and parallel to each other. As you can see in this photo, it has height and radius.
This is a cylinder. Now let's figure out its vertices. Oops, it has no vertex. Now let's figure out its edges. It has two edges. One edge is in circle at the top. The another one is circle on the bottom. Cylinder has three faces. One face is a circle on the top. Second one is the curved surface that wraps around it. Third one is also the round shaped face at the bottom. And that's the cylinder. Now, he will introduce to you the formula of a cylinder.
The solution to find the lateral area of the cylinder is lateral area equal to 2 pi multiplied by radius and multiplied by height. On the other hand, the solution in finding the surface area of the cylinder is surface area equal to lateral area plus 2 pi radius squared, or surface area 2 pi radius multiplied by height plus 2 pi radius raised to 2. So now we know the solution on how to find the lateral area and surface area of a cylinder. Let's try to solve a problem. In this problem, the cylinder has a height of 10 cm and a radius of 4 cm. The first step we need to do is to find the lateral area of the problem. The solution of the lateral area is lateral area equal to 2 pi multiplied by radius and multiplied by height. Now, substitute the given. So, lateral area equal to 2 pi multiplied by 4 and multiplied by 10. Then solve it. The answer is 80 pi centimeter squared. After we solve the lateral area of the cylinder, the next step is the surface area. The solution is surface area equal to surface area plus 2 pi multiplied by radius squared. Then substitute the given 80 pi plus 2 pi multiplied by 4 squared. Then solve it. 80 pi plus 32 pi is equal to 112 pi centimeter squared, or 351.7 centimeters squared.
Then, let us try to find out on how to compute the lateral and surface area of a composite figure.
Composite figure. Composite figure is a figure that composed or made up of two or more solids. Solids that are made up of generally are prisms, pyramids, cylinder, cone, and spheres.
Here are examples of composite figure. Now, let's try to compute the example of composite figure.
To find the lateral area and surface area of a composite figure, it is a must to know how to solve the lateral area and surface area of any kind of solids that are prisms, pyramids, cylinder, cones, and spheres. So, let us try to solve an example. Find the lateral area and surface area of a composite figure below. Round to the nearest tenths. So first, we are going to find the lateral area and the surface area of the cylinder, which is at the top. So we have 8 feet height and 4 feet radius of the cylinder. Let us now solve the lateral area with the formula L equals circumference times height, or 2 pi rh. By substituting the given, we have L equals 2 pi times 4 times 8. And with that, we get 64 pi feet squared. Next is the surface area, and the formula we will use is S equals L plus 2B, or we will come up to that S equals 2 pi RH plus 2 pi R squared. So we will use that formula, and we have S equals 2 pi times 4 times 8 plus 2 pi times 4 squared. We get 64 pi plus 32 pi equals 96 pi, or equals to 301.6 feet squared. That's the surface area of the cylinder. So next, we will find now the lateral area and the surface area of the rectangular prism, which is at the bottom. So we have here the formula of the lateral area of the rectangular prism. So L equals perimeter times height. So let us now find first the perimeter of a rectangle with the formula P equals 2 length plus 2 width. So we have P equals 2 times 14 plus 2 times 8. And we have 28 plus 16. And the perimeter is equals to 44 feet. And we will use it in solving the lateral area. The lateral area of the rectangular prism is 528 feet squared. Next is the surface area with the formula S equals perimeter times height plus twice the base area. Let us now substitute the given. So we have S equals 44 times 12 plus 2 and 14 times 8. 128 plus 224, and we have surface area of the rectangular prism is 152 feet squared. Last, we will sum up all the surface area we get, and we will subtract twice the base area of the cylinder. Why? Because the surface area of the composite figure is the sum of all areas on the exterior of the figure. So we need to subtract the two circles which is at the interior of the figure. So let's start to find the area of a circle. The area of a circle is pi r squared, and we have 4 feet of radius, so we have 16 pi, or equals to 50.3 feet squared. And now let's sum up all the surface area of the composite figure. So we have the surface area of the cylinder 301.6 feet squared plus 752 feet squared, the surface area of the prism and subtract it twice the area of the base of the cylinder, which is 50.3 feet squared. And we have 1053.6 feet squared minus 100.6 feet squared. And then we have the surface area of the composite figure, 953 feet squared. And that's how to solve and find the lateral area of the surface area of a composite figure.
Hi, I'm Nair Ortalaza and I am here to discuss the topic changing dimensions. When we say changing dimensions, it is the changes of measure or the size of an object, and it helps us to visualize the effect on the surface area. A cube has 6 equal faces, and all the faces are squared shaped. It has 8 vertices and 12 equal edges. So I have here an example that we are going to answer. The edge length of the cube is doubled. Describe the effect on the surface area if the length is 12 cm. The first thing that we have to find is the original dimension of the cube, where the length is equal to 12 cm. The formula that we are going to use is surface area equals 6 times length squared. Then we substitute. Surface area equals 6 times 12 squared. 12 squared is equal to 144 equals 6 times 144. The surface area is equal to 864 centimeter. The next one is the edge length doubled. The length here is doubled, so it will become 24 centimeter. We will use the same formula, which is surface area equals 6 times length squared. Then, we substitute the value of the doubled length. Surface area equals 6 times 24 squared. 24 squared is equal to 576. Equals 6 times 576. Surface area is equal to 3,456 centimeter. So, the original dimension is equal to 864 centimeter, while the edge length doubled is equal to 3,456 centimeter. We can now see that 3,456 is equal to 4 times 864. Doubling the dimension makes the surface area 4 times the original surface area.
And that's how we compute the lateral and surface area of a prism, pyramid, cone, cylinder, changing dimension, and composite figure. Thank you for watching.